Okay, so today you don't really learn anything new. We just put everything together. And you should have done an example yesterday on your assignment when you did this. Hopefully it worked out for you. If you didn't do yesterday's assignment, problem number 3 tells you to make an accurate graph. And hopefully that worked out for you. That's basically what we're doing today. Okay? So, when we graph stuff, okay, we should always consider a number of things that we've talked about throughout the years. Number one, look at the domain. For example, if I have y is equal to x squared, what's the domain of x squared? What's the domain of y equals the root of x? And 0. Yep. And y equals, say, 1 over x. All real numbers except for 0. Jake's on a roll today. So, yeah, so you got to think about domain, all right? Range, is your outputs. Not so critical to think about the range. That kind of comes through our other work. But intercepts, from the time you've been very young in your math career, we've talked about finding x and y intercepts. The y-intercept is generally super easy to find. How do you find it? Plug in 0 for what? Plug in 0 for x, and you get a y value. So how do you find the x value? 0 for the y value and solve for x. And that's generally more difficult because it's solved for y. And so therefore you need to go through the solving process here. And so sometimes finding x-intercepts are easy, sometimes it's very challenging. Some graphs have symmetry. For example, y is equal to x squared. Did you know that that's an even function? If you remember we talked about even and odd, what's the dead giveaway that that's an even function? Okay, exactly. It's got an even power. Those are symmetrical about the y-axis. And if you have, say, y is equal to x cubed, that's symmetrical about the, very good, the origin. So, for example, sine of x is an odd function. You don't really see a degree with it, but the fact is it's symmetrical about the origin. Cosine of x is symmetrical about the y-axis, so it's even. Asymptotes, a lot of times those happen, if we have spots where it's undefined, right? Here we have 1 over x minus 3 is equal to y. What's the vertical asymptote? Y is equal to 3. Does anybody know what the horizontal asymptote is? Very good. So the vertical asymptote is x equals 3. The horizontal asymptote is y equals 0. Aaliyah, how are you so confident that it was y equals 0? Very good. So she sees that there's no vertical shift. She doesn't know enough to really trust herself on that, but she sees that there's no vertical shift here. But here's another thing. If you let this limit go to infinity, what are you going to get? 0. That's your horizontal asymptote. Which brings us to our end behavior. We'll talk about that, then we'll talk about this other piece. End behavior is what happens when you let the limit of x go to infinity and x go to negative infinity. And often we find end behavior in those situations. The graph might have a horizontal asymptote. It might have a slant asymptote. There's all sorts of things that can happen. Okay? So we consider that. Yeah. And I totally understand that some of the problems that you're going to do today in your assignment, first of all, I cut it in about half from what I did last year, put it on a worksheet. But, the first 5 are ones that, for me, are non-negotiable. Everybody needs to be able to do the first 5. I understand that you might struggle with 6, 7, or 8, but you don't want to struggle with the first 5. But 6, 7, and 8 can be challenging when you haven't seen direct examples. Increasing, which derivative, first or second? F prime of x must be greater than 0 for it to be increasing. If it's decreasing, then f prime of x is less than 0. How about maxes and mins? Local max happens when f prime, what? Positive, negative, and min happens when f prime changes from negative to positive. That, you have to memorize these pieces, folks. I'm guessing that a lot of you think about the graph as you're doing this, correct? You just think about a cubic generally. You're like, okay, f prime is positive when it's on its way up. And I changed from positive to negative here, so it's a max. Am I right? Do you guys kind of think about that? Okay. Yeah, I always try to picture that in my brain as I'm trying to sort through these. Okay, kind of works out. And then concavity, it's concave up if f double prime of x is greater than 0. And it's concave down if f double prime of x is less than 0. Okay? So you can see in this situation I'm concave down, and in this situation I'm concave up. And the second derivative in the first situation will be negative, and then it will be positive. The one last piece I forgot to throw on here was inflection. And the point of inflection, it's a point, kind of like a local max or local min. But the point of inflection is where it changes concavity. And so that's where f double prime has a change of sign, from negative to positive, or f double prime changes from positive to negative. That's where inflection occurs. We all good? Well, let's roll. We want to be able to take this graph and sketch a perfect graph of it. Now, some of you that sounds boring. Some of you that sounds, somewhat exciting. Some of you you're like, hey, that'd be really cool if we could get a perfect graph of that without really the use of our graphing technology. And so that's what we're going to do. We're going to identify all these pieces here and go to work. I'm going to start with the, first of all, tell me anything about it. Cubic, great. So, starts down, finishes up. How do you know that? Positive, so it finishes up. Odd, so it's going to start and end in the opposite directions. Very good. Excellent. Okay? So we know that right away. And then you actually answered the end behavior. The limit as x goes to infinity, you said it's going to end up, right? You just answered that question. And the limit as x goes to negative infinity is going to be negative infinity. That's what you just stated. Everybody agree? Okay. Is there anywhere where the function's undefined? No. So we don't have any vertical asymptotes, and you don't have a horizontal asymptote because you said it heads off to infinity. Okay. So like if it headed off to 2, that would be your horizontal asymptote. And we'll get to that later. Well, if you had, like, say, 1 over x minus 3, then there's a vertical asymptote at 3. So horizontal and vertical asymptotes really come into play when you have rational functions, not when you have polynomials. Okay, y-intercept. That should be easy. What's the y-intercept? 0. Cool. Can we find the x-intercepts for this one? Yeah. So on your test, or on your assignment for today, I definitely have examples where you're finding the x-intercepts. I have some where you don't find them. Sometimes it's just really challenging if we don't want to spend too much time with it. But this is not going to be a big deal. What do? X squared minus 2x minus 3. Does that factor? X minus 3, x plus 1. So I've got zeros of, or intercepts of. Very good. Cool. We're all rolling well so far? Okay. It's time to do some derivative testing. F prime of x, first derivative. That'll tell me something about increasing and decreasing. What's the first derivative? Ooh, I don't really think that factors. What to do? Awesome. Somebody take out your calculator. Somebody who has the quadratic formula plugged into it because you watched that 4-minute, 2-second YouTube video. What do you got? 3, -4, and -3. All right, there we go. So if I make this mark here, I go -0.54 and 1.87. I want you guys to know that when I first taught this class, we would always do interval testing, meaning we would actually plug points in. But it's easier to just look at the graph. So that makes a parabola, writes it up or upside down, goes through those two spots, so I'm positive, negative, positive. That was easy. So what have I learned? What has that told me? Very good. Increasing from negative infinity to -0.54 union with 1.87 infinity. Where's it decreasing? Says the loud voice from the back. Negative 0.54, 1.87. Very good, Maddie. I don't know anything about concavity yet, do I? Was it you, Rich? Was it you? Yeah. All right, here we go. Local max. What do you think? Do we have a local max? Where is it? Negative 0.54. And I've got a y value. Who knows what it is? I'd have to plug that back in, right? That's a good question. Think about it. Think about it. Think about it. Think about it. Stop. Think about it first. If I were to plug negative 0.54 into here, what would I get? 0. That's where the derivative is 0. You don't want to plug it in there. Plug it in the original. All right. Because the maximum happens where the first derivative changes from positive to negative. We all good? You're acting like that was a dumb question. That was not a dumb question. You already know that. Okay. Throw your pencil. All right. So local min 1.87, right? Well, we can't talk about inflection yet. Well, let's move along, okay? Second derivative, what is it? So I've got what? What's my 0? 2/3. And it looks like the line looks like this, right? Okay, so I got negative positive. So that means it's concave down from, good, concave up from 2/3 to infinity. Inflection, therefore, happens at 2/3. Well, I want to get some y values here. So I'm going to go to my calculator. It's super cool. X cubed. What we got? I can't read it. Minus 2x squared? Minus 3x. Go to my table. I type in negative 0.54. And I get 0.88. Type in 1.87. And I got negative 6.1. Plug in 2/3. And I got negative 2.6. Questions back there? Okay, so now is the big moment. I want to sketch a perfect graph. You guys tell me x values. Like, where do I want to, how big do I want to make my axes here? 10 by 10, 20 by 20, 5 by 5, 2 by 2, 5 by 5? We'll go. We're talking x values. All right. You know what I was going to say. Yeah. Okay. Jeez. Oh, sounds like a dead bird. Sounds like a dying bird. Thank you. That's very good. All right. So, Kelvin, what do you want to do for the y values, dog? 7? Okay, great. Let's do 8. Levi, can you what do you mean about distorted? Like, I don't know what you're talking about. So what? Ugh. Okay. I've got x-intercepts. I've got 0. I've got negative 1. I've got positive 3. I've got a local max at negative 0.54 and 0.88. It's going to be right about there. I've got a local min at 1.87, which is almost 2, and negative 6.1. It's going to be down there. And I got inflection 2/3, negative 2.6er. Now remember, you told me that it starts down and finishes up, right? 2/3 negative 2.6. So Well, yeah, so I'm going to start down here. That wasn't very good, was it? Shoot. No, I can tell you're angry, Chickas. Just say it. Settle down, dude. All right, so we're going to take this distortion that my friend is worried about at the back there. And we're going -5 to +5, so we get rid of that distortion. And we're going to go -8 to +8 with a tick mark every 2. Well, you don't get it. Hey, what do you think? Grade me on a scale of 1 to 10. Oh, okay. You're calling me out. Just call me out. Okay. What do you give me? A 5? A 10? A 2 out of 10? B Rody, what do you give me? 2? Oh, you're ridiculous. All right. It's the last one we're doing today. We do 2 tomorrow. Okay. But let's start. Okay. Start easy. You tell me what it looks like. Where's it undefined? No. So x equals -2 is a vertical asymptote. How would you find the horizontal asymptote? You'd let the limit go to infinity, right? Not 1, but go get some brain food and come back smarter, folks. I bet Rach is on my side. Here we go. No. I was pointing to him right there, not you. I would never. I overreacted. All right, here we go. So we see that the vertical asymptote is at -2. Why? Because if you plug in, yeah, -2, you get 0 in the denominator. What I want to do is I want to look at the end behavior. If I look at the end behavior, I was hoping everybody would be able to look at this and see that the limit is 3. You see it? Okay, I'll do this one last time. If I say 3x squared plus 2x minus 1 over 4 minus x minus 4x squared, remember that these end up not really mattering at all, do they? So you end up with like a 3x squared over -4x squared. So I know that limit is -3/4 just by looking at it. So as you look at this one, we know it's going to be 3. Let's show that it is 3, okay? The limit is x goes infinity. I take an x on the top, I get a 3. I take an x on the bottom, what are you left with? 1 plus, come on, Cal, redeem yourself. 2 over x, very good. So what happens to 2 over x? Goes to 0, right? And the x's cancel, you're left with 3. So that's why you can just look at it ahead of time, see it's 3. So the end behavior is 3. That's a horizontal asymptote. If you took the limit as x goes to -infinity, would that change at all? No, it wouldn't. Okay, so you have a horizontal asymptote of 3. You all good there? All right. Intercepts. Y-intercept happens when? X is 0. Plug in 0 for x. What do you get? 0. Just close the door. All right. X-intercept happens when the function is equal to 0. I set this function equal to 0. Do I look where the top is equal to 0 or the bottom? The top. When is the top equal to 0? So I got the x-intercept, I've got the y-intercept, I've got horizontal and vertical asymptotes, I got a good start sketching this graph, but let's do some of the derivative tests, okay? Let's do it again. For the y-intercept, I plug in 0 for x, and I get 0 over 2, which is 0. Now I look for the x-intercept. That's where is this thing equal to 0. Okay, if you want to solve that, you cross multiply, and you get 0 equals 3x. Or in other words, just look at where the top is equal to 0. Where is that equal to 0? Very good. Okay, so derivative test. I need to take the derivative. What do I do? Quotient rule, derivative of the top. 3 times x plus 2 minus 3x over x plus 2 squared. What happens at the top? 3x is canceled. I'm left with 6. Is the top ever equal to 0? Is the bottom? Where? Is negative 2 part of the domain? No. J. Aki, what is the only number I cannot plug into the function? Negative 2. So is negative 2 part of the domain? So it's not a critical point. However, it could change from positive to negative there. So we have to include it in our testing. All right? What do you notice about the denominator? It's always positive. What do you notice about the numerator? Numerator, always positive. Denominator, always positive. Positive divided by positive. What does it mean if the first derivative is always positive? Does that mean it's always above the x-axis? No. It means the slope is always positive. It's always going up. The function's always on the rise. Okay? So, we are increasing from? No. Negative infinity to negative 2. Union with negative 2 to infinity. We can't include negative 2 because it's not part of the domain. No. 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 Just do this. It's not difficult. Okay. Because if you plug in negative 2 to the denominator, you get 0. Okay, is it ever decreasing? No. Do I have a local max? Do I have a local min? Look at that. You're liking this problem, aren't you? All right. F double prime of x. Somebody show me smarts, because I need it right now. I want to take the second derivative. Tell me what to do. Thank you. Let's use the chain. 6 times x plus 2 to the negative 2. Very good. Awesome. Callan got it. Derivative of the inside is 1. Derivative of the outside, negative 12 over x plus 2 to the third. True or false? The bottom's always positive. False. Top is always negative, right? But bottom changes. So we gotta consider that negative 2 spot. What value to the left of negative 2 would you like to plug in? Plug in negative 3. What do you get in the bottom? Positive or negative? Negative. So I get a negative over negative is a positive. What value to the right of negative 2 would you like to plug in? 0. You plug in 0 and you get a positive in the denominator. So a negative over a positive is a negative. What does that tell us, folks? Concave down from negative 2 to infinity. Concave up from negative infinity to negative 2. Does it change concavity? At what point? Negative 2, but is negative 2 part of the domain? So you cannot include it as an inflection point. Got that? Let's sketch an amazing graph. What would you like to make the tick marks? Want to make it 5 by 5? All right, let's go 8 by 8. You do whatever you want. Free country. Okay, I'm gonna plot the intercepts. 0, 0. I've got a vertical asymptote at -2. I have a horizontal asymptote at 3. Yep. Okay. Now, this is all I got to go on so far, but I'm going to look at my information. It says I'm always increasing. If I'm always increasing, do I draw it at the top or the bottom? And if it's in the top, would it be concave up or down? Concave up, right? So it says it's concave up from -infinity to -2. See that? So increasing and concave up. Then from -2 to infinity, is it concave up or concave down? It's concave down. And is it increasing or decreasing? So I have to draw an increasing function that is concave down. Oh, we can type that in our calculator and get a beautiful example as well. We're going to pick up the rest tomorrow.